We are here in Iceland. Well, I'm here in Idaho, but we are going to get this going thanks to our good friends at NatureEye. We're going to go ahead and get the drone up here. We are just a little bit east of Grindavik, and we're going to go check out the eruption area. So we're going to head that way. So I haven't done this in a little while, so bear with me. We do need to stay pretty close to 60 meters and keep our altitude high enough that Johan can have a good line of sight. So hopefully everyone's able to hear me okay and join me. Thanks again. I'm Geology Professor Shawn Willsey, and we're here partnered with NatureEye, the company that has the drones here. And this experience is pretty awesome. We are using the wonders of technology to go check out this eruption. And I'm the one flying the drone remotely here from Idaho. And this is something you can do as well, no matter where you're located. One of the big announcements I have for you is NatureEye now has the ability to book flights over this volcano. So if you or a loved one, we have Father's Day coming up soon. If you want to give this experience to someone where they can fly over the volcano, look at the fresh lava, and also maybe take photos, that is something you might want to check out. So I've got a link on the video description for NatureEye. And if you use the code ShawnFly, ShawnFly, you can get 10% off your flight. So something to consider there. So again, thank you so much to NatureEye for making this possible. So we're flying just along the lava berm here that sits northeast of Grindavik, and we're going to head up to over to the eruption site here. We can see some of the lava over on this side that's flowed on this side of the berm. Remember, they put up two sets of berms here, so we can see one here and then another one here on the left side. So two sets of defensive berms. And with these past eruptions, we can see that the lava has filled in pretty close to the brim here on this first one, and that necessitated that second berm over there. So flying over the lava field here, keeping my elevation kind of close to 60, so we have a good line of sight. You can see the gas plume coming out of the eruptive vent. We're down to just one spatter cone that's been erupting over the past week or so. This eruption's gone on a little more than a week now. Over here, if we scroll over here, we can see the power plant and the Blue Lagoon area, the gap between the hills there. And this is Hagafelt, this hill right here that we're coming up on. And so most of what you're seeing below us here is fresh rock. This is all recently erupted material from the May 29th eruption. Over here, we should have this large, fracture or crack from the eruption. I haven't got a full bead on exactly what took place here. I think the fissure may have propagated and opened up a crack further to the south, but that fracture or crack never actually fully erupted. So I'm here at the controls, and we can look down with the camera, kind of swing it down a little bit. That might help us see a little bit more of the glow as we kind of move along here. Let's bring the camera back up a little bit. Yeah, and here's that fracture right here. Maybe take a picture. We can zoom in as well. You can see us zooming in. So the camera capabilities on this are pretty nice. Of course, we're kind of we got a little bit of sunlight here. So you've got zoom options on the camera, which is really pretty amazing. And then the ability to just keep moving the drone around 360 degrees, up, down, left, right. Looks like we had some of the lava come up right here and spill out of this part of the fissure, looks like to me. Again, I haven't, this is my first time flying over this landscape and really kind of taking it in. So I'm learning on the fly along with you. But let's head up a little further to the eruptive cone, excuse me, which is over here just to our right. And this cone's built up about maybe close to 30 meters now. It's at least 20 meters tall, so 60 or so feet tall. Um, and it sits more or less in between those two hills, Silingerfeld and Hagafeld. And it's feeding a lava, perched lava pond that comes out this south side here. Swing over here. Yeah, a lot of gas coming out of this side on the west side of the flow. And we can see a little bit of the glow there. The spatter cone's still erupting, but we have get down to 60 meters here, down to my, there we go. But we do have some lava that's coming out of this south side of the cone. So we'll be able to see that as we get a little closer. And I can already see a little bit of the glow from here. We might even try using a little bit of the zoom while we're moving along here. And then tilt the camera up a little bit. Oh, let's back off on the camera a little bit. Oh, so apparently a lot of what I thought was gas over there on the west, that's a lot of moss fires that we're seeing over on that side. So pretty amazing. And the winds are pretty strong here, so we're doing the best we can with the winds. And Johan, I'm disabled here, so hopefully you've got this thing right now. There we go. Okay, so I'm back on now. Thank you. Yeah, so here's our eruptive cone. And let's maybe just kind of park here for a second. Maybe get a little bit closer and take a look at, I think we're kind of going into the wind here, so the drone's working extra hard. And we probably won't have much time here, but we can cruise back and get another battery charge and maybe zoom back up. We can see some of the lava coming out of the base of the spatter cone. And remember, these spatter cones are kind of prone to collapse, and they'll build up, they'll kind of collapse back down. Let's get a little closer with the camera if we can. So here's, bring it up a little bit. You can see the lava pouring out right here. Zoom in a little further for you. So you can see there's a opening at the base of the cone, and the lava is pouring out and feeding this flow field here. If we had a little darker visibility, this would be a little bit more dramatic than during daylight time. Yeah, and if you can just, this isn't that hard. If you think this is beyond you to control the drone, if I can do it, anyone can do it. So this is, basically just, you can see the keys on the screen there, just forwards, backwards, up and down, that sort of thing. So there's our nice little cone there. Let's try to look down a little bit more. Whoops, the other down. And maybe move, let's zoom back out a little bit and take a look at the flow field. We have this perched lava pond right in front of us here. Um, and so there's not a ton of material coming out of this last vent. Let me swing around this way. Yeah, the lighting makes it a little tricky to see um, all the lava. And let's try going down with the camera this way. But you can see some of the different textures there. The flow field. Trying to master the controls here. I don't think I'm quite ready for, the great footage, Hollywood movie making yet. Whoops. And okay, there we go. So one more look at the cone there. And you can see, here's a good spot to see the perched pond. Let's see if I can master this a little better for you. Yeah, so the lava flow coming out the base here and then feeding. You can see the levees that go around this perched lava pond. A little bit of surging there as the material in the spatter cone kind of moves into this channel. And we'll get a quick picture there. And we'll probably have to head back and recharge the battery. Again, we're just lucky we can do it with the winds that we have here. So Johan's going to bring us back in. You'll notice that at this point, the flight will be much smoother than when I was flying it. But again, pretty awesome, pretty neat to be able to move over this landscape, be able to look at the things you want to see as you go. And it's all pretty easy to do just with your keyboard. Just a couple little controls, just forwards, backwards, left, right. So if this looks like something that you or someone would be interested in, again, the good folks at NatureEye can make that happen. And they have not only this location, but other locations in various places around the world, depending on the landscape or the type of area you want to investigate. And if you sign up for one of these Iceland volcano flights, I think you'd have Johan here. He would be your drone pilot, and he can walk you through it, and he can take over if anything starts going awry, or if you get too far out of range or anything like that. So you can't screw up. You got a safety net there. So we're looking sort of southeast here at the east side of Godindavik, some of the little farms and houses, and there's a view looking towards the harbor in the main part of town, and all this lava that's poured down along the berm here. So remember, in the March 16th eruption, the leading edge of this came fairly close, maybe a half a kilometer or so from the road. And there was even some thought and speculation about it actually going into the ocean. And luckily that didn't happen. And with this last eruption, we didn't see any further progress beyond this termination we see here, thankfully. But they have these double lava barriers now set up at several key places, so that if it overtops that first one, there's a second barrier to continue to hopefully divert the flow around the town. So we'll let Johan take us back in, do a quick battery recharge, and then we'll go back out and do a little bit more flying, taking some photos. So you're able to take photos with this, and then those photos get uploaded and you can keep those later. So a nice sunny day in Iceland, but not the best lighting conditions for looking at some of the lava. So we'll land here, let Johan switch out the battery, and then we'll go from there. I can see the live chat. So a couple questions here. Susan wants to know, how high can they build the berms? I think I stood next to the one at the Blue Lagoon. It's a legit 10, maybe a little bit more than that meters, so 30 to 35 feet. I think they could build them higher than that, but obviously, the taller it is, it needs a broader base, and so there's plenty of material there, and so I don't know that they'll, eventually be putting them up any higher than that, but that's about how high they've been so far. So, um, yeah, so we'll get a battery change here, and then we'll head back out and see what else we can see. Um, Maybe fly a little bit further to the west this time, and maybe we can see some of those moss fires. I'd like to see the berms over there on the west side. Probably a little too far for us to get north of the cone. There is a little finger of lava that's wrapping around the north side of Selingerfelt, that hill there, but it's not. It's close to the road there, but it's not really advancing much. So, and I'll talk you through that on the update. So when we get done with this next little flight here with Johan and NatureEye, please stay tuned, and I'll provide a brief update of some of the things that's been happening in Iceland over this past week, and maybe do some questions. We'll have to see how it looks time wise. I've got to get home and get some stuff done and some packing done. So, but happy to have you along, and happy to have you join in on this wherever you're joining from. So as soon as we get the new battery in, and I get the go ahead from Johan, we can take off from there. Yes, Robin King is asking if there's just one cone going. Yeah, just one spatter cone, one vent that is currently erupting. And the big question would be, will that thing keep chugging along like we saw with the March 16th eruption? Or will it quickly dissipate and die down like we saw with some of those previous eruptions? So looks like we got a new fresh battery. So thank you, Johan, for that. Much appreciated. And as soon as he gives me the green light, we'll be good to go. Yeah, the wind can really drain the battery when the drone's taking off in the wind. Looks like I got the takeoff button, so we'll go ahead and take off and head back out. Thank you, Johan. So here we are looking more or less due north. And I think I want to kind of head this way a little bit. Get dropped down a little bit there. It's hard to keep that 60-meter ceiling because the land surface changes. So as we go further north and it rises, I can go up a little higher, but then we have to drop back down. So looking right at Thorpjord there, the hill straight in front of us. And if we swing around this way, we can see most of Grindavik there. So there's the town. Take a picture there. And then we'll kind of head back up over the eruption site here. So swing around to the northwest. And then we'll kind of head this way. And Humphrey wants to know if he can approach the area from the road, the road to the Blue Lagoon. I believe he can. Yeah, maybe we can, when we end this flight here, we can bring Johan on and we can ask him about that. He has a couple different options for where he accesses this area, and sometimes it's in his hands as to where he goes, and sometimes it's not. He has to go where the civil defense or other public officials, where they're allowing him to get in. This may be, there was a little section of the berm or lava barrier that was producing some gas, and I believe that's right in front of us here. The building to the left is the abandoned greenhouse. And best guess as to what this is this may just be a continuation, a fracture that connects to the eruptive fissures at depth, and so it's just actively degassing, and so it's producing some of this gas here that you can see just straight in front of us. And then most of the lava right here in the foreground, this would be from the January 14th eruption, which actually erupted partially through the lava barrier. We can see some of that active degassing there. Yeah, and these lava fields can have just so many different types of textures, depending on the the temperature of the lava, the speed at which it's flowing, and the terrain it's flowing over. You can get, these smooth Pahoehoe flows. You can get these more rubbly flows, and then lots of different textures in between. And we have names for all of these. In science, we're good at coming up with all sorts of names. Um, so view to the east there. Looks like there might be a moss fire out that way as well, down low. That's, of course, towards the 2021 eruption sites at Fagradalsfjall. There's this big fracture again. Yeah, that's a very wide crack there. So you can see sort of, I mean, it's a combination of these volcanic processes, but also the faulting that results in just these dramatic features on the landscape. Both these cracks in the ground, some of which erupt material at times, and just this terrain. So it's pretty incredible to think how much this landscape has changed. I think we did one of our first flights with NatureEye in mid-December, and at that time there was no eruption, if you remember correctly. And I think we might have even flown over this area the day before it erupted. That's what my memory is telling me, but we could double check the dates there. But very, very soon, close to that eruption date, is when we flew over this area, and of course, it looked quite a bit different. And I know Gylfi at Just Icelandic wants to document all those changes with the drone flights, which I think is just really awesome to be able to show. Here's what this area looked like in mid-December. Here's what it looked like, a month or so later, and just because several of these eruptions have overlapped in terms of spatially, the area where the lava has covered, and each eruption creates new topography, which influences the next subsequent eruption. And so, even these perched lava ponds and some of these other features we see here, they all have a role to play in determining exactly how the next eruption's lava, where it's going to go, how it might progress, that sort of thing. Yeah, so a little hard to see to the west with the sun over there, the late evening sun, but we can see some of the apparently the moss fires. So along the perimeter of the lava field, the heat from the lava has actually ignited some of the moss that is draped over the older topography, and so that's what's creating all the smoke we see there, at least in the distance. But straight in front of us, that's 100% volcanic gases, water vapor, hydrogen sulfide, and such that's coming out. So we'll head back over here. Again, it's a nice clear day so that we can see far, which is great. But part of me wishes it was it was a little cloudier so we could see the incandescent glow maybe a little bit better. So, and I wonder if we're kind of pushing the drone's range here, but I think we're good. I try to keep it right close to 60 meters. Occasionally the screen pixelates a little bit depending on the signal, but all things being equal, it's pretty awesome technology we have that we're able to do this. And so they've got the Starlink setup that allows me to connect into the drone, even though I'm literally many thousands of miles away. And so let's see if we can get it a little closer view of the cone. Yeah, there's and then the camera up a little bit. Oops, sorry. There we go. So we can see some of that lava flowing out of the cone. Just really awesome there. Just a great look at it. And let's see if we can go a little closer, but then also a little bit to the left here. Yeah, as you can see that perched lava pond there in the foreground. Let's zoom back out just a skosh. And obviously we don't want to get too close to the erupting spatter cone, because literally a chunk of spatter hitting the drone would be bad news. But this is a nice view here of these flows. And go down a little bit here. Yeah, awesome. So there's still some gases in these flows as they're coming out. So you can see some of that bubbling up here in the foreground. So we've got the lava flow coming out of the spatter cone into this perched lava pond. And either a little bit of gas left over, or we could be seeing some of these darkened crustal slabs sinking, what we call crustal foundering. Looks like they are sinking in there a little bit. Let's go see if we can check those out a little bit better. And swing the camera down just a little bit. Let's see. My screen just went blank, Johan. Everything okay on your end? Oh, there we go. Awesome. Yeah, so if we can, let's zoom back out a little bit, and let's come up this way. Kind of make sure where we are, and swing around this way. There we go. There's our view. Yeah, so like, look, you can see the breach in the spatter cone there, where the lava is just kind of pouring out of the base through some of the gas there. And let's see if we can zoom in a little further. Oh, that's just, there you go, team. Like, yeah, so you can actually see pieces of the crust that are sinking down into the lava flow here. Again, that's called foundering. Pretty common in lava flows that behave this way, where the top layer is hardened, but it's more dense than the hotter material below. So it will tend to sink over time. Let's see if we can move a little bit to the side here and get away from the gases a bit. Yep. Oh, we ran out of battery. Well, that was pretty sweet though, getting up there and checking that out. So yeah, that was kind of fun for me to be able to get back in the saddle, so to speak, and try getting the drone in there and getting used to the controls again. So pretty fun. Yeah, it has a great zoom lens on it. So hopefully folks are enjoying that. And again, this, why should I have all the fun, right? You can jump on NatureEye's website and sign up for one of these flights on your own, or give it as a gift to someone that you think might be interested, and have at it. There'll be a little bit of coordination, I imagine, with NatureEye and Johan in terms of picking a day where they've got a good weather forecast and the conditions look good. But Johan tells me I think the next couple days, or maybe Sunday, is a pretty good day. So there might be a good little window coming up. So yeah, and let's if you want to, Johan, you can unmute and jump on, and let's see if we can if you can answer. Someone had a question about if you could have accessed the area from the Blue Lagoon today. Was that an option for you? See if we can get him on. Then you guys can hear from him directly. So yeah, he might not be able to hear me, or is maybe focused on getting the drone back. So, but I'll try to get an answer for you on that front and in that regard. So we'll enjoy the view flying back towards the south end here, over the distal end of the March 16th flow. And then when we get the drone landed, we'll say goodbye to our NatureEye friends, and then I'll share with you, if you're interested. I've got a little bit of material ready to go to show you just kind of the latest data and some of the information that we've got on this eruption. And we can talk a little bit about what might be coming next, and sort of our long range, forecast for the eruption. Yeah, someone asked if we can see the photos somewhere later. Yeah, I'll ask Amanda Joe to maybe remind me, and on one of the next live streams, I can share some of those photos. I don't have access to them now. Johan, they get recorded by the drone, but then Johan can upload those to my NatureEye account, and then I have access to those. So, wow, he just cruises in and parks that thing on a dime. So awesome. Well done. Well, we'll go ahead and sign off then with NatureEye. So thanks again to Johan and NatureEye. One last little time here to let you know that if you want to do a NatureEye flight, you can use this promo code Shawn, SHAWN, my name, and then FLY. So Shawn Fly will get you 10% off a flight. So go to natureye.com if you want to book that. And one of the new options they now have is a flight on the Reykjanes Peninsula, where you can check out this eruption while it's taking place. So hopefully that's something of interest to you potentially. So, okay, I'm going to switch over to, let's see here. Let me switch over to another window here, and we can kind of run through a quick little summary on what's been going on the Reykjanes Peninsula. Oh, let me actually, I think it looked better when I had it, yeah, like that before. So there's the cone we just went by. This is just one of the live cams here. Let's get it up to speed. So we just saw all that. We do have a new Met Office update that we can go through. So let me switch to that. The tricky thing is it doesn't, let's see. Oh, we need to go to a window. Here we go. Okay. Now I've got it figured out, team. Much better. Okay, so here's our latest Met Office update. And I'll make that a little bit bigger for you to read if you want to read along with me. So the activity of the volcano remains fairly constant recent days. This is an update from today, about 3:20 Iceland time. So activity confined to one specific crater with fairly constant output. The flows are mainly going to the northwest, but there is a little bit ponding there to the south. That's exactly what we saw on our flight there. Is as we approached in from the south, we could see some of that lava was ponding there. But there is another lobe of the flow. I believe some of the lava is coming out of the north end of the spatter cone, and it's swinging around the side of Svartsengi, or not Svartsengi, Slingerfeld, to the hill there. Land stopped sinking in Svartsengi. We'll look at that. That's some of the GPS data that's of interest. And yeah, just gases, of course, down in Grindavik, depending on the wind direction. So the eruption continues. It's now been 9 days since it started. One crater is still active. Lava flows mostly to the northwest towards Slingerfeld, where the lava bed thickens, but there are active flows north. From there are active flows north of Slingerfeld. They have a nice little satellite image here that shows us. And I don't think it has I don't know if we can zoom in on this a little bit or not. maybe not a ton, but this does show you the active spatter cone right here, the little orange dot with some of the material coming out here. There's some of the ponding in that perched lava pond immediately south of the spatter cone. And then there's a flow that emanates from the north side of the spatter cone that wraps around the hill here, Sedlingarfeld. But that flow as at its maximum extent, it's close to the road, but hasn't quite reached it. And I think if we maintain this, even though assuming the volume of material doesn't increase in terms of output from this thing, it'd probably be a long shot for it to actually get across the road there. But you can see the defensive berm here, Blue Lagoon, the power plant, Thorpjord here, and the hills that kind of define this area. So a nice little satellite image. You can also see the rest of Godindavik, the defensive berm, the January 14th fissure that opened up in town. And then Johan was operating the drone from somewhere right in this area here. So we flew, well, we actually ended up flowing. I think he's actually here, maybe more like somewhere in this area. But we flew over the berm and then headed out towards the spatter cone. So other parts of the update, we'll get to this. Let's see. The lava bed area is about 8.6 square kilometers, and the volume is about 36 million cubic meters. So that's the full volume of the lava field. Based on these measurements, the average lava flow from the eruption from its inception to January 3rd was about 30 cubic meters per second. So that's pretty high. It probably was higher on May 29th. I think we even saw numbers that were maybe over 1,000, but that's just averaged over that 5 or 6 day period. These results are based on data covering about 70% of the lava width, but it's assumed there have been no significant changes in the lava width outside that area between measurements. And then the one crater is active still, excuse me, but they estimate that the flow rate now, kind of what we just saw with the drone there, is about 3 to 4 cubic meters per second. Or that's what they're estimating based on similar looking eruptive style from the last eruption. So that's probably pretty close to what we're seeing in terms of output, maybe a little bit higher than that, but that's probably in the ballpark. Then the next part of the update deals with the GPS measurements and the vertical movement of the ground in this area. So land subsidence was measured in the first few days after the eruption, which was different than what we'd seen in the past. Usually with all the other eruptions, as soon as the eruption had ended, and sometimes when it hadn't even quite ended, we had seen a inflation cycle. So we saw the land rising. And here, as we'll get to in a second, when we look at the GPS graphs, it did the opposite. We saw deflation or subsidence. And this indicated that a greater amount of magma flowed from the storage zone to the surface than flowed into it from depth. So we were pumping out more lava than was accumulating in the subsurface. Deformation measurements over the past few days show land subsidence seems to have stopped, and therefore it's likely that the flow of magma from depth into the magma accumulation area is now comparable to what's on the surface. So we think now what's coming in and what's going out, at least right now, it seems to look like it's more or less in balance there. And then the last thing in the update that we'll address here, and I've got some other things that we'll cover as well, is the University of Iceland has some of the geochemical data. They took a sample of this magma when it started erupting, and so we'll look at some of those results as well. But here's the latest little graph. Let me shrink that down a bit here. So all these colored lines are previous eruptions or intrusion events and how many days it took to get to that eruption event. So we just came off of this yellow one here, and then we finally got to an eruption on out here past day 70 with a total magma volume of something around 20 million cubic meters. And now we're the red line. And so we actually had a drop in the magma supply or a decrease in elevation. And so the question is, where will this go? What will the trajectory of this thing look like over the next few days, weeks, and maybe even months? So let's look at the GPS data first, and then we'll come back to this. So Here's the Svartsengi station. Here's the eruption on around May 29th. So you can see a pronounced movement to the north at this station. Also a pronounced movement to the west, shown by this downdrop here on the green line. So things moved north and west at this station. And that makes sense because this station is near the power plant. And so it was shoved to the northwest as the magma came up through the fissure and sort of pushed the ground apart as the lava was erupting. But here's the part that's interesting. Make sure my face isn't covering that. So here was the eruption way back on March 16th. And right after the eruption began, we saw the GPS data more or less kind of level out, maybe a slight increase or inflation trend, and then we started to see that pick up a little more in a little more pronounced way all through April into most of May, and then that finally reached a head with the eruption on the 29th. So the deflation is to be expected after the eruption, and there was a considerable amount of magma to that was erupted there. But then what's most interesting about this is you would have expected this to maybe either stay flat initially and then start to pick up, or even pick up right from the get-go. But what we actually saw was a bit of a deflationary trend in the first few days after the eruption. And now looking at these last few data points, again, by no means conclusive. We'll have to wait and see how this plays out over the next few days. But it looks to be kind of leveling out, as if there's no net up or down movement for the most part over the last few days at this station. And so will this start to pick up and come back up, showing more of an inflationary trend? That's probably what I would expect, especially if the eruption stops completely. But that will be kind of the wait and see learning moment for all of us. So a very interesting trend that we see right here. Let's see. So we have that. We have real briefly, earthquakes are pretty easy to cover. There's essentially very few, essentially none in the area around Grindavik over the last 24 hours. So earthquakes are pretty much a big zero because we've already established pathways, and that magma isn't not pressurized, has no need to break rock and produce more earthquakes. And then, of course, we had the geochemical data come out from the University of Iceland and looking at the samples of lava and looking at their chemistry. And so here is a high-powered microscopic view through a thin slice of those rocks, that fresh lava. And they've identified some of the major minerals that are in there. So these weird geometric shapes you see in here are crystals. Most of these black sort of rectangular needles in there, these are plagioclase crystals. So it's a common mineral we see in basalt. Usually shows up as even though in here it looks dark, and if you could see it big enough in a hand sample in a rock, it would be a needle-like white crystal. And then little bits of olivine, which if you could see it in natural light would be a green, kind of olive colored. And then this is pyroxene or clinopyroxene, another mineral that's pretty common in basalts as well. And then there's a little gas bubble in there. And then most of this light gray material in the background, that's just glass. So that's lava that's been quenched so quickly that crystals haven't had time to form. So I'll put a link to this in the video description as well, but they do a little write up here on the material. They sort of state here that the lithological characteristics of the new lava are similar to previous lavas that have flown out of Sunux Giga since December 2023. So superficially, they look very much the same in terms of their mineral compositions and that sort of thing. In looking a little bit deeper at the chemistry, they primarily look at magnesium oxide and then a ratio of potassium oxide to titanium oxide, that ratio there. And I'm no geochemist, so I can't explain this in excruciating detail. But what is of interest here is looking at all the other data plotted up from other eruptions in the region. So all these gray dots here are geochemical signatures from the 2021 Fagradalsfjall eruptions. And then these other symbols here are samples taken from the last few eruptions in the area. So going back from December, there's the circle, January is the square. So that one was a little bit different in terms of magnesium composition, a little bit lower. February and March tracked very closely, and these all came out of the same vent or same area, I suppose, not the exact same vent, but same area. And then our May samples are plotting up down here. So a little bit of a different trend in terms of the magnesium's pretty close to the same amount, but lower potassium titanium ratios here. And so here they offer a possible interpretation. The magma most likely accumulated in a separate magma reservoir in the mid crust, distinct from that from the eruption in March. This should be March, not Martian. The magma that's now emerging at Sunukskiga has a ratio similar to that of the magma that emerged at the beginning of the Geldingdaler eruption in 2021. One possible explanation for this is that the two magma systems are connected deep down in the Earth crust. So essentially, we are probably, as the magma is coming up, it may be tapping other regions or pathways, intersecting, cutting across pathways or regions of magma that fed these previous eruptions. And so you're getting a little bit of mixing, and that's shifting the chemistry of the lava just a little bit. And so it's of interest. And they'll continue to, of course, take samples with each subsequent eruption to see exactly how the magma might be evolving. Maybe it all stays the same from here on out, but we might see it trending in one way or another and possibly indicating that the magma's coming from a deeper source, or it might be evolving a little bit more and doing a little bit of crystallization before it comes up. So pretty interesting stuff. So we've got the geochemistry there if you want to deep dive into that on your Friday evening or Saturday morning, as the case may be. And then a news story. And as always, thanks to Amanda Joe for getting me some of the news items that are out there. Much appreciated. Remember that the electricity was severed in Godindavik because the power poles that were elevated above the area, there was just so much radiant heat from that big lava flow initially on May 29th that it caught those poles on fire, cut off the electricity. But now they have established the electricity with a 4-kilometer long cable that comes from the Svartsengi power plant. So the overhead line was damaged. Not sure what the plan is long term for that, but at least for now, they've got the electricity flowing again in the town. And so, yeah, he says not sure exactly what they're going to do long term, if they're going to try to put the poles back up or, yeah, but they've got some time probably to figure that out while maybe waiting for the next eruption. So I think that's all I had for the update. Let me see what time it is. I could probably do a few questions. I don't know if there's been questions sent, Amanda Joe. Let me come in here and look. Well, let me give you something better to look at than a white screen. That's kind of terrible. Let's see, where do we want to go here? Yeah, we could come back and maybe look at the satellite image or something. And then let me double check my email and see. So yeah, Amanda Joe, if you have just maybe, I don't know, 5 or 6 questions to round out our little session here, that would be fine by me. I think I can make time for that. Make sure, folks, that please, if you can like and subscribe, make sure you're subscribed, like the video for today. All those good things are very helpful. So yeah, let's see what else we have here. A couple people have donated, and I want to thank them. Sharon Idles, Dexterity and Artistry, thank you for your kind donation. There may have been some others here as well. I'm kind of catching up on the live chat here, team. If you did donate, thanks so much. Yeah, appreciate your support. And let's see, she's got possibly, here we go. Here's my email sheet. Thank you, Amanda Joe. Okay, couple quick questions, and then we'll call it a session. So thank you, viewers, for your questions, and thanks Amanda Joe and Susan for your awesome job moderating. Okay, let's see if I can handle these or not. From Estrame, could you ask Shawn to explain why 20 million cubic meters becomes 36 million cubic meters at the surface for those who don't understand how gas bubbles increase the volume of the lava. Oh yeah, that's a good one. The way I understand it, so yeah, if you've been paying close attention to the numbers, um, that might have jumped out at you. And maybe we can actually, maybe I can bring the, let me see if I can put the questions up for folks. That might be a nice touch here. Let's try going to this. There we go. So the 20 million cubic meters of magma was an estimate based on the modeling of the ground deformation. So as we looked at how much the ground had deformed leading up to the eruption, that was our estimate, not precise, but probably a good number and in the ballpark of how much magma was in storage in the subsurface. The actual magma that's erupted, we have a much better handle on how much has erupted because we can measure the area of the lava flow field. We can measure its thickness in many places. And so that volume is better established, I would say. I think that's a pretty safe bet. The reason that they're different, as the viewer here so astutely alluded to, is that when that magma comes up to the surface, now it's lava, we give it a different name, it's carrying those dissolved gases with it. And so those gases cause the lava to, upon eruption, expand. It might be throwing out pieces of spatter. It might be inflating the lava flow field itself. If you walked out on these fairly recent lava flow fields, it's not dense solid rock by any means. There's a lot of gas bubbles in it. And so so then by nature, the total volume is much greater because you're accounting for the gases that are trapped in the lava coming out. And so that's the way I understand it. And hopefully that jives with, that makes sense to you folks. From T. Zaras to, please don't forget to let Shawn know of the geochemical report. Oh, I kind of went over that, which had less, potassium to titanium. I had to research a little about what that meant. If I read a few research papers correctly, the magma could be recycled melt instead of from a deep source. And so what that means, and I'm no geochemist either, so you might know more about this than I do, but it could be that as that magma sat in that storage zone, that it was recycling, it was partially melting some of the adjacent rocks and incorporating that material, and therefore just changing its chemistry ever so slightly. Fundamentally, it's all the same rock type. It's all basalt, but the geochemists do a good job of analyzing these rocks and looking at the chemistry in very minute detail, and they can glean little hints and clues in there that help us understand the journey that the magma's had from where it was generated at depth to the surface. And sometimes it comes through the system quickly without really changing, but sometimes it comes up, stays underground for a while, like we saw under Svartsengi, has some residence time at some intermediate location before it actually erupts. And that's when a lot of times when its chemistry can change a little bit, it can grow larger crystals perhaps. So hopefully that helps a little bit. Mr. Muppet fan, if a cinder cone grows large enough, does it become something else like a shield volcano? Generally not, because they're erupting in two very different ways. So a cinder cone, which is very similar to a spatter cone, but instead of globs and blobs of lava, would be throwing out much smaller particles, more frothy bits. But cinder cones and spatter cones grow by lava being ejected in the air, piling up around the vent, and it will form a steep-sided cone. As we've seen with the case with the spatter cones, it's kind of a balancing act between building up as more lava and spatter accumulates on the rim, and then also inside the crater, because it's very hot, it can undercut parts of those walls, the crater rim walls, and it can collapse. And so it's this balancing act between the two. So a spatter cone just typically won't get as big as you might think. And cinder cones can't become shield volcanoes either. And here's the reason why. Shield volcanoes, rather than the lava being thrown out and accumulating, the lava just pours out effusively, doesn't get ejected into the air. So that hot lava just pours out more or less in all directions and builds up that low profile, low angle shield volcano shape. So hopefully that helps a little bit there. Ninek Whitman, how do the denser cooled pieces of lava stay on top of the molten stuff? Surface tension or a very other mechanism, seeing as it's rock, not water? Yeah, good question. I think that might have stemmed from when we were looking down at some of those rafted crustal blocks that eventually sort of sink down. Um, I think it's mainly a density issue, the way I understand it. I don't know how much surface tension plays into it, so it's a good question. Um, I don't have, I don't know. That's the best answer. But I think that it's just a density issue. If the lava carrying the slabs progressively gets a little bit hotter and a little bit less viscous and a little bit less dense, those slabs will start to sink. Or if the slabs on top progressively get cooler and more dense, even if the lava beneath it stays the same temperature, they'll have a propensity to sink. And there's probably some other dynamics in there. You might also factor in the movement of the material, the topography it's running over. You probably can have other situations where it's more likely to run into something and sink or something like that. So, yeah, good question. You guys are getting me thinking, which I love. Moonchild, Straver, how hot are these gases actually that we can see? 100, 250, 500 hotter. Boy, I mean, coming right out of the vent, you're looking at lava that's probably, oh crap, I got to do Celsius now. 1,000, 1,100 degrees Celsius. So the gases easily could be initially coming right out of the vent, pretty close to that, maybe 800 degrees Celsius, but they would quickly cool as they expand and move away from the heat source, the lava that carried them. And so by the time, they're maybe 30, 50 meters away, I would guess they've cooled substantially. But it sort of depends on how big the lava field is. Like in 2018, when I flew in a helicopter over the big, I don't remember how wide that thing was. Let's say it was 400 meters wide. That's probably pretty good. The very hot, very low viscosity lava channel in Hawaii in 2018, we were probably a couple thousand feet above the lava, and we could still feel the radiant heat. Like it was very noticeable. That heat was moving that far. So, um, yeah. So good question. There's probably a graph somewhere someone could find about gas temperature at an active eruption like this, and then the other axis might be like distance away from the actual vent that it comes out of. So, but I would guess that your higher number there is probably more in the range, at least where we see that very blue glow of those sulfur-rich gases. And then our last question here from DJI Mini 2. In this system, at what depth does degassing occur? Is the rising magma commingling with gas bubbles, or is the lion's share of the degassing in the last few meters before the surface? Another great question. You guys are on fire on a Friday. That's great. I think the main factor there is the couple things. The amount of gases you have trapped in the magma, so the actual gas content by volume in the magma. Second thing would be pressure of the overlying rock on that magma body. And then also the viscosity of that magma. If it's relatively cooler or more silica rich, it's harder for the gases to escape. And so not a lot of degassing occurs until it's pretty much right at the surface versus a basaltic system like we have here in Iceland. We're probably getting degassing occurring probably as deep as 100 meters below the surface, just from there up, right? From 100 meters to the surface, I would guess that would be where a considerable amount of degassing is going on. And we did see places as we flew over with the drone where there were just not even steam, but clearly volcanic gases, judging by the color, coming up right out of either the berm or the lava field. And so those areas of degassing are probably within a few meters or tens of meters, but maybe even deeper than that. So great questions. yeah, ones that I wish I had more precise answers for you. But maybe I've given you some food for thought at any rate. So um, good stuff here, team. Anything else? Let me just check real quick the few conduits I have here. Oh, I did hear back from Johan. He says the answer is yes, I can fly in from the north, but the wind is even stronger up there now. The drone is a flying weather station, and we were getting up to 17 meters per second on our flight. And he can see the wind speed on the software when he's flying. So sounds like we did not fly. The Blue Lagoon was closer. So I get the question that people had is like, hey, why didn't you take off from the Blue Lagoon, zip right over to the thing, and we're there? But the wind being out of the north, it was stronger winds. And I think he was hoping or betting on starting to the south and staying low and going further, that we wouldn't have to be fighting those strong winds as much. So so there's the answer to that question that someone had that came up. Yeah, I think we did it here, team. Nice work. Thank you for all the folks that donated. It was really fun to do this live stream today. I'm really excited. I know we had kind of a lull in the drone flight and the whole NatureEye thing, but it seems like they're in a better place now and able to offer this a lot more moving forward. So I will, of course, reach out to them as much as possible, especially if a new eruption takes place or there's something awesome to go see and fly over. So I will look to pair up with them as much as possible. We have a good relationship. I was able to meet Johan on this last trip to Iceland. It's a win-win for both of us. It helps me by making the live stream experience on my channel with you good people better, because we're able to use our own drone footage, which we don't have to deal with copyright issues with other drone pilots. And it helps NatureEye because it helps get the word out about their company. So one last time, if you want to do NatureEye flight, you can use the code, and it's under the video description, Shawn Fly. That'll give you 10% off. Great Father's Day present if you want to, coming up. A lot of fun. I mean, I guess I've only done, no, I guess I have done some of these drone flights when it wasn't to live stream. Early on, they just let me kind of play with it. And that was super fun. And I still want to do a flight in North Iceland with Johan, because he's from that area, over Lake Mývatn and Clairfjall and some of the cool volcanic features in that area. But apparently they just got socked by a crazy June snowstorm. And so that might not be happening till later in the summer. So anyway, folks, thanks again for joining me. Thank you, as always, to our amazing moderators, Susan and Mandy Joe, for their help in managing the live chat. I will be gone the next week to South Carolina with my family and my wife's extended family. But I will bring my computer, and if something substantial happens at Kilauea, Iceland, or otherwise, and I can jump on and share that with you, I will, of course, do that. I did launch today a brand new lecture number 2, episode 2 of the Geology 101 series. So if you watched the first episode, the second one that is waiting for you. If you haven't watched either of those are great videos to start with. If you want to learn geology for the first time, you've gotten interested in it, but you haven't really had much of a formal or informal education, or maybe you've had geology classes and education back in the day, but you're looking for a little bit of a refresher, or maybe you just want to see what Shawn Willsey's kind of version of a Geology 101 education looks like. But these are essentially my college classes, the exact lectures and slides and things that I do with my classes, for the most part, delivered to you here on YouTube. The only thing you don't have is the labs, the field trips, of course. But you guys have lots of opportunities to go on virtual field trips with me through all the videos I have out there. So it's a great way to learn more about geology if you'd like to. So that's out there. The other video I have that's coming out probably, I don't know when I'll launch it, probably this weekend. That sounds as good as anything. Maybe tomorrow. Last night, I did a presentation to the Icelandic League of the United States. It's an organization that is paired up with, they are people that live in the United States, but have either ties to Iceland through family, or people just that love Iceland and want to be connected to it. And so I did a presentation to that group online that dealt with sort of the history of the Reykjanes area and these eruptions. So if you've been following me all along since October, um, you'll recognize most of that story. But if you've kind of come in a little late or haven't caught all the details, there might be some nice little nuggets in there for you. So I just got a copy of that presentation from them, and I'm going to make sure I get that uploaded and probably launch sometime this weekend. So there'll be a couple videos coming out while I'm gone, and if anything happens, I'll be sure to jump on and do either a live stream or video update for you. So thanks as always to our moderators. Thank you all for joining me. You guys make this channel and this community stand out as an exceptionally positive and awesome place for learning and sharing. So thank you for all you do to support the channel and what we do here. And with that, I'll go ahead and say goodbye and take care, and we'll see you next time.